Today we will discuss about how to find the transfer function of a system represented by a signal flow graph. So we know signal flow graph representation, or to find the transfer function using signal flow graph representation is much easier compared to block diagram. In signal flow graph representation, we can find the transfer function using the Mason's gain formula or directly using Mason's rule. So here the question is, find the transfer function C of s by R of s for the signal flow graph in the figure given below. So you can see here R of s is the input, C of s is the output, and there are several nodes that are connected here. The input node is R of s, output node is C of s. In between there are several nodes like V1, V2, V3, V4, etc. And the branches that connected in between two nodes having transmittance or gain like G1 of s, G2 of s, G3 of s, G4 of s, G5 of s. There is also some feedback paths like H2 of s, H1 of s, and another feedback paths like you can see here another feedback paths. So our aim is to find the transfer function using Mason's gain formula for the given signal flow graph. So in signal flow graph method, the first step is to find the forward paths. To identify what are the forward paths of the given signal flow graph and write their gain, forward path gains. So the first step is to identify what are the forward paths and write the forward path gains. So in this question, we can see that there is only one forward path, that is starting from R of s to C of s. Okay, this is a forward path that is starting from R of s to C of s, that R of s into V4, V4 into R of s to V4, V4 to V3, V3 to V2, V2 to V1 and V1 to C. That is the traveling of input to output node, and we can write the transfer function or gain of that forward path is equal to G1 of s into G2 of s into G3 of s into G4 of s into G5 of s. So if you closely check in this SFG, there is only one forward path that starts from input to and reaches at the output node. From input node to output node, there is only one forward path. You can see the its direction should be from input to output. So only one forward path here. Now the next step is to identify what are the loops. What are the loops in this signal flow graph? That is the next step. So the first step is to identify the forward path. You can see there is only one forward path, that this straight line, that is a forward path, and we can write the transfer function of that forward path. Okay, the next step is to identify what are the feedback loops. So we can see here there is one loop. What is that one loop? We can represent it as L1. L1 is the loop that starts from here and from the node V3 it returning back to node V4. So we can write the loop transfer function of L1 is equal to G2 of s, H1 of s. Okay, it starts from here in this point and reaches the node V3, then it returning back to V4. So we can write the transfer function of L1, loop 1 is equal to G2 of s into H1 of s. Similarly, there is another loop L2 that starts from the node V2 and reaches to V1, again returning back to V2. So we can write the transfer function of loop L2 as G4 of s into H2 of s, and here L3, that is another loop that's starting from here and again returning back. So we can write the equation as that starts from, you can see that the L3 loop, there is a difference in the L3 loop. The L3 loop is starting from here through the path H4, through the branch H4. It reaches to where? It reaches to node V5. From V6 through the path or through the branch H4 of us, it reaches to V5 of us and again returning back through the path G7 of us. So the loop L3 having the transfer function G7 of us into H4 of us. Okay, so if you closely check, there is again another loop that starts from here and it goes through G2 of us, G3 of us, G4 of us, G5 of us, and when it reaches this point, it returning through the path G6 of us, G7 of us, and again reaching in the same node V4. So this one is another loop. We can call it as L4. L4 has the gain G2 of us into G3 of us, G4 of us, G5 of us, G6 of us, G7 of us, G8 of us. This is again another loop. So we can see that there are 4 loops in this SFG. Now, if you got the forward path and if you got the loops, we can now write the equation. What is our equation for Mason's gain rule or Mason's gain formula? C by R, or transfer function C of S by R of S, is equal to sigma I is equal to 1 to n pi delta I divided by delta. What is n? N is the number of forward paths. So here in this question, how many forward paths are there? You can see only one forward path is there. So n is equal to 1. N is equal to 1 in this question. Hence, our equation C by R is equal to P1 delta 1 divided by delta. That is our equation for transfer function. C by R is equal to P1 delta 1 by delta. What is P1? P1 is the gain of first forward path. Delta 1, delta is the determinant or characteristic equation of the signal flow graph, and delta 1 is that part of delta. Delta 1 is that part of delta which do not touch the first forward path. So delta 1 is that part of delta which do not touch the first forward path. What does it mean? That means in delta, if some terms or some parts of delta, if not related with the first forward path, that will be delta 1. We will explain this with the help of this problem. Now, the next step, for the first step is to write the forward path, identify the forward path and write the gains of forward paths. Next step is to identify the feedback loops and write the gains, loop transfer functions of the feedback loops. And the next step is to write the equation with respect to Mason's gain rule. Here there is only, since there is only one forward path, our transfer function equation using Mason's gain formula is C by R is equal to P1 delta 1 by delta. Now we can check whether there is any non-touching loops, any two non-touching loops are present. We can check whether there is any two non-touching loops are present. So here in this question you can see that loop L1 and loop L2 are non-touching. Loop L1 and loop L2 are non-touching because they do not have any physical contact here. And loop L1 and L3, that is also non-touching loops. L1 and L3, that is also non-touching loops. Also we can see loop L2 and loop L3, that is also non-touching. You consider L4. When you consider L4, L4 is this loop, that is starting from this point, it reaches again here. So we can see that this L4 touches all the other loops, L1, L2 and L3. L4 എന്ന് പറയുന്നത് ഈ ബാക്കി 3 ലൂപ്സിൻ്റെയും ഏതെങ്കിലും പാർട്ടിൽ കൂടെ കടന്നു പോയിട്ടുണ്ട് അല്ലേ, ഏതെങ്കിലും ഒരു പാർട്ടിൽ കൂടെ. ഇപ്പം ഹിയർ യു ക്യാൻ സീ ദാറ്റ് ഇൻ ദ L1 it touches the path G2, branch G2. In L2 it touches the branch G4. In L3 it touches the branch G7. Hence L4 എന്ന് പറയുന്ന loop that touches all other loops. So the next step is we have to identify whether there are any two non-touching loops. So we got as L1 and L3 are two non-touching loops, L1 and L2 are two non-touching loops, and L2 and L3 are other two non-touching loops. So we can write the equation of that. That is the loop gains of all two possible non-touching loops. So we can see the loop gains of L1 is G2H1, L2, loop gain of L2 is G4H2. So loop gain of L1 and L2 is G2H1, G4H2. Now we can see L2 and L3. L2 and L3 are two non-touching loops. So we can write the loop gains of L2 and L3. That is G4H2, G7H4. Now L1 and L3 are also non-touching loops, two non-touching loops. So we can write the loop gain of L1 and loop gain of L3. That is G2H1, G7H4. So the next step is identify whether there is any two non-touching loops. If there is any two non-touching loops, or if there are non-touching loops present, you have to write the loop gains of or product of all possible combinations of two non-touching loops. Products of gains of all possible combinations of two non-touching loops. Why are we taking two non-touching loops? Possible combinations of two non-touching loops, because when you see the equation of delta, you can see that the equation of delta or determinant of a signal flow graph is 1 minus sum of all feedback loops, sum of gains of all feedback loops, plus sum of combinations of loop gains of all possible two non-touching loops, minus sum of combinations of loop gains of all possible three non-touching loops, plus etc. You can see that delta is 1 minus sum of all individual loop gains plus sum of products of gains of all possible two non-touching loops. Two loops that do not touch each other means two non-touching loops, minus sum of products of the gains of all possible three non-touching loops, plus etc. So we have to write the possible combinations of all two non-touching loops. That is the next step. Then the next step is we have to check whether there is any three non-touching loops present in the signal flow graph. So if you check, you can see that loop L1, loop L2 and loop L3 are three non-touching loops because they do not have any physical contact. So in this question, three non-touching loops are also present. So we have to write the combinations of all three non-touching loops. So that is the next step. Non-touching loops taken three at a time, or all possible combinations of three non-touching loops. If you check, you can see that only one combination is there because there are only 4 loops here, and this L4 is contacted or connected with all other loops. So the possible combinations of three non-touching loops are L1, L2 and L3. So we have to write the loop transfer functions of L1, L2 and L3, product of loop transfer functions of L1, L2 and L3, that is shown here. That is the next step. Now after getting this, we can write the equation of delta, because if you check, there is no possible combinations of 4 non-touching loops. Okay, only there are 4 loops, and this L4 is connected with all other loops. So there are no possible combinations of 4 non-touching loops. So we can write delta as delta is equal to 1 minus sum of loop gains of or feedback loops plus sum of all possible combinations of product of any 2 non-touching loops plus all possible combinations of product of any 3 non-touching loops. So we can write delta is equal to 1 minus L1 plus L2 plus L3 plus L4. 1 minus of L1 plus L2 plus L3 plus L4. The loop gains of L1, L2, L3, L4 are shown here. Then plus inside the bracket the combinations of 2 non-touching loops, that are L1, L2, L2, L3 and L1, L3, that shown here. Inside the bracket the combinations of 2 non-touching loops. We can see that the combinations of 2 non-touching loops, the product of combinations of 2 non-touching loops are written here. So we have to take this. So the next term is inside the bracket plus combinations of all possible 2 non-touching loops, that is shown here. Then the next term is minus inside the bracket all possible combinations of 3 non-touching loops, that is shown here. The 3 non-touching loop, that is L1, L2 into L3, that is shown here. This is our delta. So we have equation C by R is equal to P1 delta 1 by delta. Since we have only one forward path, the equation will be P1 delta 1 divided by delta. So we already got P1, that is the first forward path, and we also got delta, that is the determinant or characteristic equation. Now we have to find delta 1. What is delta 1? That part of delta that do not touch the first forward path. That means first forward path ടച്ച് ചെയ്യാത്ത ഡെൽറ്റയുടെ പോർഷൻ. അപ്പോൾ നമ്മുടെ ഫസ്റ്റ് ഫോർവേഡ് പാത്ത് എന്താണെന്ന് എല്ലാവർക്കും അറിയാം. വാട്ട് ഈസ് അവർ ഫസ്റ്റ് ഫോർവേഡ് പാത്ത്? ഇതാണ് നമ്മുടെ ഫസ്റ്റ് ഫോർവേഡ് പാത്ത് അല്ലേ, ദിസ് സ്ട്രേറ്റ് ലൈൻ. ആകെ നമുക്കിവിടെ ഒരു ഫോർവേഡ് പാത്ത് മാത്രമേ ഉള്ളൂ. ഇതാണ് നമ്മുടെ ഫസ്റ്റ് ഫോർവേഡ് പാത്ത്, ദാറ്റ് ഈസ് സ്റ്റാർട്ടിങ് ഫ്രം ആർ ഓഫ് എസ് ടു സി ഓഫ് എസ്. ഈ സ്ട്രേറ്റിലാണ് നമ്മുടെ ഫസ്റ്റ് ഫോർവേഡ് പാത്ത്. നിങ്ങൾ നോക്കിക്കഴിഞ്ഞാൽ യു ക്യാൻ സീ ദാറ്റ് L1, ലൂപ്പ് L1, ലൂപ്പ് L2 ആൻഡ് ലൂപ്പ് L3 ഈ 3 ലൂപ്പും ഇവിടെ കോണ്ടാക്റ്റ് ഉണ്ട്. Loop L1, loop L2 and loop L3 have contact with the first forward path. Only loop L3 loop do not have any contact with the forward path, first forward path. So we can write delta 1 as that part of delta which do not have any contact with the first forward path. അപ്പോൾ ഫസ്റ്റ് ഫോർവേഡ് പാത്തിൽ കോണ്ടാക്റ്റ് ഇല്ലാത്ത ഡെൽറ്റയുടെ പോർഷൻ എന്തായിരുന്നു? ദാറ്റ് ഈസ് ഓൺലി L3. അല്ലെങ്കിൽ ബാക്കി എല്ലാ ടേംസും ഫസ്റ്റ് ഫോർവേഡ് പാത്ത് ആയിട്ട് കോണ്ടാക്റ്റ് വരുന്നതാണ്. സോ വി ക്യാൻ റൈറ്റ് ഡെൽറ്റ 1 ഈസ് ഈക്വൽ ടു 1 മൈനസ് L3, ലൂപ്പ് L3, ദാറ്റ് ഈസ് അവർ ഡെൽറ്റ 1. സോ വി ഗോട്ട് ഡെൽറ്റ 1 ഈസ് ഈക്വൽ ടു 1 മൈനസ് G7 ഓഫ് S H4 ഓഫ് S. Now we can write the transfer function is equal to P1 delta 1 divided by delta. For P1 you have to substitute the equation with G1, G2, G4 etc. And delta 1 you can substitute this equation. For delta you can substitute this equation. That will be your final answer. Okay, thank you.